Now, my name is John Shaw, and I'm one of the co-hosts here at Let's Talk Energy, where our goal is to enable collaboration amongst energy professionals to share best practices, technologies, government regulations, and quite frankly, anything that's changing the energy markets here in Canada. The format for these webinars is fairly unstructured. We do have a few slides just to kickstart the conversation, but we do encourage participation from the audience. We want to hear from you, your questions, your comments, any projects that you're working on that might be related to today's topic. There's two ways that you can get involved in the conversation in today's webinar. The first is via chat. So on the right-hand side, everybody should have a chat widget. Any point in time, feel free to write questions, submit your comments. We'll be monitoring that and bringing them to the panel for discussion as we move along. And the second way to join the conversation is via, you can raise your hand. So next to your name in the same widget, there's a little hand icon. If you press that, we'll get a notification that you have a comment or a question, and we'll unmute you and go from there. So just a quick recap of the Let's Talk Energy. So this is episode 2. In episode 1, we talked about the ICI changes and how that's impacting large electric power consumers in Ontario, specifically Class A customers. Today in episode 2, we're going to switch our focus to the world of controls, switchgear, and paralleling. And with that, we have 3 experts with a combined 80 years experience in consulting and designing on large electric power. So without further ado, I'd like to introduce you to our panel this afternoon. Our first guest speaker is Akhila Shankar. Akhila, thanks for taking the time this afternoon. Can you just take a moment to introduce yourself to the audience, please?
Sure, John. Good afternoon, everyone. My name is Akhila Shankar. I'm an electrical engineer with over 25 years of experience in the industry. I'm a consultants account manager at Toromont, and I'm responsible for supporting consultants in southwestern Ontario, Manitoba, Newfoundland, and the Atlantic provinces. My hobbies outside of work include sketching and artwork with paper, jute, beads, textiles, etc. Back to you, John.
Thanks, Akhila. And one thing you didn't mention there, but I'll throw it out there, is you recently became a distinguished Toastmaster. That's quite an accomplishment. Congratulations there.
Thank you.
Moving on to our second panelist today, Chris Dorelyers. Chris, can you take a moment to introduce yourself to our audience, please?
Sure, John. My name is Chris Dorelyers, Switchgear and Retrofit Business Manager at Toromont Power Systems. I've been in the business for over 20 years, and my background is as an electrical engineer designing and programming controls for generator paralleling switchgear. When I'm not at work, I enjoy downhill skiing and fishing with my kids. Over to you, John.
Thanks, Chris. And our third panelist this afternoon, Habib Aleemi. Habib, can you introduce yourself for a moment, please?
Sure, John. Good afternoon, everyone. My name is Habib Aleemi. I started my work with Toromont as electrical engineer 12 years ago. Now I'm working as a senior electrical controls estimator. During the last 12 years, I worked in many marine and EPG power generation projects. My hobby is playing chess when I have time. Back to you, John.
Thanks, Habib. Okay, let's get started with episode 2, best practices for designing controls and switchgear. To get started and get us in the right mindset, we'll start with a fairly basic question, and I'm going to throw this over to you to start, Akhila. What are the benefits of paralleling gensets?
John, there are 4 advantages of operating gensets in parallel. The first one is redundancy. Redundancy is inherent when you operate multiple generators in parallel, and this provides greater reliability than a single generator serving critical loads in a system. The second advantage is efficiency, and the higher efficiency comes mainly from monitoring the load demand within the system and determining the optimum number of gensets required to be running at any given point in time to supply the loads in the system. The third is the expandability, and this is achieved because paralleling systems can be designed with the future expansion in mind. And last but not the least, the ease of maintenance. And this is realized because planned maintenance and shutdown of equipment becomes possible without losing backup power to the critical loads when you have 2 or more gensets.
Thanks, Akhila. Chris, do we have anything from the audience just yet?
Not just of yet.
Okay, moving on. So this next question actually comes from our audience before the presentation. And Akhila, I'll start with you again. Is paralleling medium voltage gensets similar to paralleling low voltage gensets?
Yes, the answer would be yes. Paralleling medium voltage gensets is similar to that of low voltage gensets. Technically, 2 generators at any voltage can be parallel together as long as their frequencies and voltages are the same at the point of interconnection. However, there are different factors that determine what voltage is best suited for a given system. Some of these factors would include the incoming utility supply voltage, the voltage requirements of the major loads within the facility, the total system short circuit currents that would become available, the arc flash mitigation requirements in the system, the distance between generators and the loads being served. These determine the voltage best suited. However, in terms of paralleling, it would be similar whether it's a medium voltage or low voltage genset.
Thanks, Akhila. Chris, I know you actually took a look at this question as well too. Can you elaborate on why you would use medium voltage versus low voltage design?
Sure, John. There are a number of different reasons why one may use a medium voltage design over a low voltage design. One such example could be a generator fault current sizing. In many cases, for large low voltage generators, the fault current is often high. On typical switchgear, the maximum kiloampere or Ka rating for switchgear of any voltage is typically 100 Ka. So John, if we go to the next slide, we take this example here, and if we were to take a look at the low voltage option, 600 volt, and we were to try to parallel 3 generators, we can see that down under the red item here, we have about 45 Ka of fault current that is produced by each generator. And as we can see, that sum total would exceed the 100 Ka rating. So the option then under design would be to look at a 4160 volt solution. And we can see here that that solution, each generator is arriving around 18 Ka. So you can fit underneath the 100 Ka rating. So that's an example of fault current design. Another example is distribution architecture. You may find that when trying to apply a standby plant to an existing site, the incoming architecture is all medium voltage. And for most part, the downstream architecture up until a certain point is medium voltage. In this case, the best selection for putting in a medium voltage standby plant, or is putting in a medium voltage standby plant. And this saves on cable cost, saves on switchgear bus costs, transformers, etc. Back over to you, John.
Thanks, Chris. Okay, moving on to the project design. And I'll start with you again, Akhila, on this question. At what stage of product design should there be a discussion of synchronizing controls?
John, ideally, this discussion on synchronizing controls should begin once the single line diagram is drawn up. It is the right time to talk about the preferred synchronizing control solution, meaning do they want the sync controls installed on the generator, or should it be part of the switchgear and PLC controls section separately? The preferred type of PLC to be used meaning do they want redundant PLC or a non-redundant PLC? What kind of load management is required? Should that be integrated with the Sync Controls PLC, or is it a part of the building SCADA system? What is the type of communication protocol required? The need for external generator protection relay, differential protection, generator neutral grounding, all of these points have to be addressed and discussed once the single line diagram is drawn up, and that's the right time to do it.
That makes sense in a perfect world, but that doesn't necessarily always happen. Habib, maybe can you speak to some of the challenges that arise when we don't have those discussions at this stage?
Sure, John. As we mentioned, it's very important to discuss about the controls during creating single line with an expert. These discussions will minimize the cost and complexity of the system. Challenges that we see in some of our projects are complexity of the system, having extra equipment such as breakers, protection relays, unnecessarily redundant controls and equipment. If you can go to the next slide, John. As you can see in this diagram or picture, generator 1 and 2 is connected to one bus and generator 3 is connected to the second bus. Both buses are connected through a tie breaker with each other. And in this kind of system, if we could remove the tie from both buses and have all generators connected in one bus, it makes the system simpler and we use less equipment in the system. Billow points should be considered during discussion with an expert. What kind of controller genset should have, for example, what kind of EMCP, MCP 4.2, 4.3, 4.4, IO modules, RTD modules, and so on, and how gensets should be parallel with each other, how generators should be parallel with the utility, how generators should be connected to the switchgear to minimize the controls and number of breakers in the system, what kind of synchronizer is required, can we use onboard paralleling controls or a custom paralleling controls, what kind of protection relay and PLC is required, what type of communication protocol is required for the customer interface, and how and for how long we require the data to be saved in the system. And location of the control is important also. Does the customer want it within the switchgear or they have to be built in a standalone panel? Back to you, John.
Thanks, Habib. Akhila, you touched on onboard paralleling versus custom control paralleling. How do you determine when an onboard paralleling will suffice versus the need to go with custom controls paralleling?
John, the onboard paralleling solution is the basic cost-effective option for synchronizing multiple generators onto a common bus. If you can change the slide, please. In this case, the paralleling controller, which is for Toromont, it's the EMCP 4.4, and the generator main breaker, both of them would be installed on the genset for 600 volts and lower voltages. In the case of medium voltage genset, the breaker could be part of a switchgear lineup. The EMCP 4.4, which is the onboard paralleling controller, is suitable for paralleling a maximum of 8 units when they are hardwired interconnected, or a maximum of 16 units when they are Ethernet-based interconnection is used. This onboard paralleling controller, along with the wall mount master control panel, can be used for paralleling a single genset to a single utility feed as well. The onboard paralleling controller is not suitable for systems with more than one utility feed, and this is also not suitable when there is a tiebreaker on the generator bus, and the generators have to be synchronized across the tiebreaker. In that case, next slide, please, John. In that case, that's where the custom switchgear and paralleling control solution comes into picture. This, our second solution, this offers flexibility and customization in design of controls. In addition to controlling generator sets, the PLC-based controls can also integrate automatic transfer switches, UPS, and other balance of plant devices like the fuel tanks, chillers, battery systems, etc., and also communicate with the building management systems. This solution allows for multiple generator paralleling in island mode, as well as paralleling to multiple utilities or multiple tie breakers as well. And system level data can be displayed on touchscreen system HMIs. In short, we can offer the most flexible and customizable design that is supplier agnostic, meaning we can use any breaker manufacturer in the switchgear and any PLC that the customer desires. Back to you, John.
Thanks, Akhila. So you touched on PLCs and redundancy there, which I know you have a lot of experience with estimating. Can you comment on some of the factors that determine whether you use a redundant or a non-redundant PLC control system?
Sure, John. Redundant PLC is used in the system to minimize the single point of failure, increase the reliability of the system, and keep equipment and people safe. Control engineer should consider if continuous process is required or how critical the industry is when choosing redundant PLC. Based on the site requirement, we can choose the level of redundancy. For example, if redundant CPU and with non-redundant I/O is required, or redundant CPU with redundant I/O is required in the system. Back to you, John.
Thanks, Habib. Actually, here's a question from the chat, Akhila. And it says, you recommend that these sync control discussions should happen once the single drying has been created. Who do you recommend should be involved in these discussions?
John, these discussions should take place between the project engineers at the consulting firm and a technical representative from the genset and controls manufacturer. Toromont has recognized the value of supporting consultants in the preliminary stage of a project, and my services as a consultant account manager is offered at no cost to the consultants. We believe this paves way for a smooth bidding and project execution in the later stages of the project. And as the consultant account manager, I will gladly participate in these discussions with the consultant and assist with genset sizing, selection of the most suitable product for the application, and even help with the generator room design. Back to you.
Thanks, Akhila. Chris, just a quick check on the chat there. Do we have any questions to be brought up?
We do have a couple of questions that are suiting just as we're talking about controls and switchgear design. First question is, what is the best practices when designing connectivity for remote monitoring and control for data acquisition? I'll take this one, John. So remote monitoring has evolved quite a bit over the last number of years, and it's always a bit of a discussion on what data do you mine and how do we go about that. But there's a couple of fundamental things to look at. The very first question that one should ask themselves is, what is the communication method from site to the UI user interface? Is it going to be on a local area network? And with that comes questions on, is there security issues with the client doing that? Should it be cellular? Or are you far enough up north in a mining site or whatever that it has to be satellite? So that's kind of the fundamental infrastructure question. Then the second part of that question is, do you have multiple units on the site? Whether you're a standby system or a prime system, the number of units actually does make a difference. And the reason for that, as Habib was talking about the single line and understanding what kind of controls are going to be put in place. The one thing you want to do with multiple units is you want to make sure you can aggregate all of that information into one area. By doing that, you make it very easy then to apply a remote monitoring overlay. So in any design with multiple systems, you want to aggregate all your generator data, balance of plant data into one area, such as a PLC. And from there, the second thing you want to make sure that PLC has a mechanism for delivering that data, i.e. a Modbus TCP/IP pipeline out. If with respect to looking at maybe the differences with types of data that you want to aggregate between standby and prime, for standby, the key thing is we want to make sure the generator can start. So data such as looking at coolant temperature, reason that's important, if you get a low coolant temperature, unit's not on, most likely you have a block heater failure. Battery voltage and battery charger status, key. Without battery, engine won't start. And then of course, fuel level, critical to make sure that you're ready to run and you have the adequate fuel to do so. And other things on standby are online, offline, and if at all possible, bringing in, the ATS status if there's an ATS. That way, sometimes you can tell whether or not that generator is running and your power is returned back to normal, but you have not transferred back. Saves a lofty fuel bill. On the prime power side, the focus shifts to running and trending. So looking at coolant system, looking at, let's say, your turbo temperatures, looking at other temperatures in the system, your fuel system pressures and so forth. From there, one can take a look at long-term trending analysis because these things are running continuously and you can foresee potential problems. And as we move forward with our technology and aggregate this data from site into the cloud, different types of analytical analysis can be done and performed in time to give one a better feeling of where that generator's maintenance needs to be done and what type of things may be potentially coming up. The second question we actually have, Habib, maybe I'll let you take this, is we have a discussion around medium voltage versus low voltage, and should we take what should we consider when, let's say, we want to meet 100 millisecond transfer time? Should the permissive signals route through the PLC, or should it go direct? What's your thoughts there?
Sure, Chris. When considering 100 millisecond paralleling with the utility, most of the time utility is involved also, and they want to monitor the grid that generators are not parallel more than 100 millisecond with the utility. With this kind of application, mainly we have protection relays in the system. We have PLCs in the system also to give permissive to the closing and opening of the both breakers. And mainly we have a controller that controls the utility and generator breaker at the same time to achieve that 100 millisecond paralleling. And also sometimes utility requirement is to have RTAC in the system to communicate those timing with their system. And if goes beyond 100 millisecond, the transfer trip system will trip the generator breaker or utility breaker, depends on their application for these kind of systems.
Excellent. Thank you, Habib. And maybe just to add to that comment, if you're looking at a switchgear design and you're concerned about meeting 100 milliseconds for closed transition and your routing of permissives, understanding the cycle time of your breakers and working with your counterpart from your generator manufacturer, we can take a look at whether or not we have to use things like solid state relays. Some breakers, depending on if you're in medium voltage, your cycle time may go up. And there are little tricks to bringing that down in a timing diagram, and we can do that analysis ahead of time. So that's one little thing to be aware of to all those online here, that that actually can be sorted out ahead of time. Back to you, John.
All right, great. Thanks, Chris and Habib there. Moving on to the next question, and Akhila, you did touch on this a little bit, but you can maybe go into a little bit more detail. Can you describe the benefits of why the generator manufacturer should be the system integrator for both the generator and the switchgear and controls?
Our customers use their generation assets very differently, from standby systems to cogeneration to global adjustment mitigation to prime power applications. So when you couple the application variability with the variation in actual site electrical schemes, like the voltage, local utility codes, and other variables, you begin to get an idea of the importance of the depth of engineering these systems require. It requires an interesting mix of generator system knowledge, as well as electrical and mechanical engineering and PLC programming expertise as well. The applications and design engineering team at Toromont has deep experience not only in generator site controls, but also at system level automation, as well as construction, interconnection, and protection of the downstream electrical system. And this allows for us to provide a system with a specific sequence of operation that's tailor-made to meet the application. So although the reasons for needing on-site generation could be varied, you see that in every case, we have to remember the generator is not just an independent component, but it's a complex, dynamically responsive piece of the total electrical system. And as far as the customer is concerned, it's a major investment for them. So the team at Toromont can certainly help ensure that this investment on a customer's part provides the safest and the most efficient and reliable power system to meet their specific application demands. And another important point is genset manufacturers can also offer integrated shop testing of the genset with the switchgear and prove it as a system before shipping it to site.
Great, thanks, Akhila. One thing you mentioned there was global adjustment mitigation strategy, which is a bit of a hot topic around here these days. Chris, you've been involved in a number of GA mitigation projects. Can you speak to some of the considerations you have to take in when using an existing asset as part of a global mitigation strategy?
Sure. Well, to start, yes, we've had many customer requests for new equipment to be GA mitigation ready. In this case, the generators can be supplied directly with selective catalytic reduction, or SCRs, for emissions compliance. And the controls and switchgear can be designed to meet the customer operating needs. When we speak about retrofit, we do have requests where we try to get the existing power generation assets ready for global adjustment mitigation programs. And specifically, some of the upgrades that come up are we can add SCRs to address emission requirements from the Ministry of Environment. Additionally, we can add hardware and software to address connection, impact, assessment and agreement requirements from the local utility, such as adding monitoring and control to meet the requirements of the local utility company for transfer trip schemes. The other things that we can do, and that often comes up as a part of this, is just upgrading the controls and switchgear to allow systems to operate in a maybe was traditionally open transition, but move it to a closed transition system. And the reason for that is under a participation of GA mitigation, it may be highly disruptive to have power bumps when you want to participate in this program. So we do provide retrofits to the switchgear to move them to closed transition. And to the question earlier from the audience about meeting 100 milliseconds, so forth, those are additional assessments we can do to take a look at cycle times, alter permissive signal design to meet that 100 milliseconds, and ultimately actually demonstrate that to the PUC. Back to you, John.
Great, thank you, Chris. Moving on, we have another question that came from the audience before the webinar. And Akhila, I'll direct this one to you. Is it possible to ensure paralleling of multiple gensets under 10 seconds?
The answer is yes. For applications where it is critical to expedite the paralleling of multiple generators onto a common bus, Toromont offers what we call as controlled excitation paralleling, which can bring multiple generators online within 10 seconds. And this can be offered for both low voltage as well as medium voltage gensets. However, there is one point to be noted, that CSA 282 does not require all gensets to be paralleled under 10 seconds. CSA recognizes that the traditional paralleling controls cannot guarantee paralleling of multiple gensets within 10 seconds. And therefore, CSA requires the smallest generator in the system to be sized in such a way that it can handle all of the critical loads in that system. So if that smallest unit happens to be the first one to come online, it is ready to supply the critical loads. But we at Toromont, we do offer the controlled excitation paralleling, which can bring gensets online within 10 seconds.
Okay, thanks, Akhila. So controlled excitation paralleling, that is a relatively new term for me. Chris, can you explain a little bit more on what that is?
Sure, John. Control excitation paralleling, or CEP, is a generator synchronizing control scheme that allows the system to start with all the generator breakers closed and then simultaneously control each of the generator's field excitation until the desired generator output voltage and frequency is obtained within a 10-second period. This allows multiple high-capacity generators to be paralleled at the same time to deliver the required output power to building loads. This is particularly useful when there is a requirement to power large critical loads, as Akhila mentioned above, within a 10-second period. Over to you.
So Akhila, do you have any examples then where CEP would be required or written into a spec?
We actually have examples of over 15 hospital projects in Eastern Canada where synchronization of multiple units, diesel gensets, was achieved under 10 seconds. And synchronizing of these multiple gensets within 10 seconds each and every time is guaranteed using CEP. And this design has been fine-tuned and proven over the last decade at dozens of hospital sites. And it is to be noted that we are talking about synchronizing multiple large units like 1 megawatt, 1.5, and 2 megawatt within 10 seconds.
Okay, thanks, Akhila. Chris, any questions from the audience in relation to CEP or anything else for that matter?
No, not on CEP. I'll have
Okay.
some at the end.
Okay, sounds good. We'll move on to our final slide of the afternoon. And Akhila, I'll ask you this. What additional resources would you recommend for consultants and end users during preliminary design?
As I mentioned earlier, Toromont offers the services of a consultant account manager who can assist in the areas of sizing of genset, selection of the product, providing technical data, and selecting auxiliary equipment like the remote radiator, emission after treatment, enclosure, and also assist with the generator room design. Caterpillar offers several online tools or programs and services. SpecSizer is one of them, and this is the online sizing program, which can be used for sizing both diesel and natural gas gensets. And SpecSizer homepage is a great place to find links to cat.com, to Cat Electric Power News, to the upcoming events at Caterpillar, to all the white papers that Caterpillar has published, the webinars, podcasts, and power profiles. There is also this additional portal, which is called as TIP, the Technical Information Portal, which is an engine generator selection tool, online tool, which is designed to recommend the right Caterpillar product for the customer's needs. This tool also provides consultants with technical data, installation drawings, and product sizing information, as well as detailed comparison of products as well. Again, from the Spexizer homepage, you can access white papers, and there are several white papers related to generator set operation and performance, gas gensets, genset ratings, emission and certification, combined heat and power, microgrid, renewable energy applications, data center application, as well as nuclear applications. Again, Caterpillar conducts quarterly webinars and podcasts on various topics, and links to these as well is available on the Spexizer homepage. Back to you, John.
Spexizer and TIP, those are both free tools for anybody to use?
That's correct.
Okay, so we'll send out links to those resources after the webinar in the email as well too. Thanks, Akhila. Okay, with that, I'd like to turn it over to the audience. And if anybody has any questions or comments or projects you're working on and just want to get some answers or get some opinions, feel free. Chris, you said you have a couple questions already?
Yes. Is the 10-second true for gas engines? Akhila.
The projects that we have done so far have been with diesel generator sets. Caterpillar has a lineup of standby natural gas gensets, which can start and be ready to accept load within 10 seconds. We are yet to design a project which brings in multiple gensets and parallel them under 10 seconds. But based on the controls that go on the natural gas genset, I believe it is feasible, but we are yet to prove it with a project.
Okay, thank you, Akhila. The other question, Akhila, is what are the best practices? What is different between designing a standby plant and a prime power plant?
The main difference between standby generator and a prime rated genset comes from the number of hours the units are operated in a year. While the prime units run for anywhere from 10 to 15 hours per day, the standby gensets will run only a couple of 100 hours per year. So the chances of failures are higher in the case of the prime gensets because of the higher usage. So the customer would want faster and better protection of the asset and faster and better recognition of failure conditions as well. So I'm sure they would be open to considering external multifunction generator protection relays to be used on prime gensets, while on standby gensets, they could be operated with the protection that is inbuilt into the genset controller itself. Genset controllers, the standard, the EMCP 4.2, 4.3, they have built-in functions for engine and generator protection, and that would be adequate if you're talking about standby application. But when you go in for prime power application, external multi-function relays for generator protection as well as utility protection, if you're paralleling with the utility, would be required. Again, paralleling with utility, the local utility company would specify certain protection functions like the DF by DT relay, or the reverse power protection, or under frequency protection. They could be mandated by the utility company to be included in the controls. So that is what I see would be the difference between the two. Back to you, John.
Do you have any other questions there, Chris, from the chat?
Yeah, just a couple more here. Maybe Habib, can diesels be paralleled with natural gas generators?
Sure, Chris. The answer is yes. We have examples of these projects in Ontario that we parallel diesel generator with the natural gas generators. However, the diesel generators have a better transient response compared to natural gas gensets. If loads are sensitive to voltage and frequency depth, or there is limitation, it is better to bring the diesel generator first online and then parallel the natural gas generator to the bus. The diesel gensets have higher power density and therefore would have a larger kilowatt rating than natural gas genset for a given footprint. Back to you, John.
Any other questions, Chris?
Yes, one more. It's what should be considered when integrating energy storage systems with controls and switchgear. Maybe I'll take that one, John. And Akhila, I'll get you to chime in. So actually, there's a number of different things that need to be considered when integrating an energy storage system in with let's say, a conventional switchgear and power generation system, whether it's standby or prime. Energy storage systems are often coupled with the microgrid aspect as well. But a couple of key things is definitely in the sizing of your generators. What are you trying to accomplish with your battery? How much time do you want the battery to run and provide how much load for a certain period of time? And there's a careful dynamic between, your genset size and your battery size from a costing standpoint. With respect to controls, there's Caterpillar does offer controls that work with energy storage systems. If you're integrating with microgrid as well, we as well can take microgrid signals and modify our control system to properly bias our, let's say, base load set point of the generator with the microgrid. So you optimize the fuel usage. It's a careful balance. We have a lot of information, and what we're going to do with regards to this question is we've got some great literature that we'll be sending out as a part of this event, and we'll get that out to all the people that have attended this. Akhila, did you want to add anything with regards to spec sizer or any of that from your
Yes, when you have energy storage system as part of microgrid application, the generator, when you're sizing the genset, you also need to take into account the charging current that would be required by these battery storage system as well. So in addition to the plant loads, the generator would be supplying the charging current for the batteries as well as the supplying the plant loads. It is kind of similar to sizing a genset when you have a UPS in the system. So that has to be taken into account for sizing the genset for the energy storage application.
Thank you.
Chris, do we have any more questions from the audience?
I don't see any at this point.
Okay, perfect. So then with that, we will close it. If anybody does have any questions or they want to follow up, Akhila, Chris, and Habib, you can find them on LinkedIn. You will send over their contact information in the follow-up email. Thank you, everybody, for joining us this afternoon. Our next episode, episode 3, will focus on managed energy services. That is on November 18th. Managed energy services is a relatively new concept to electric power. So we'll be joined by Electra Utilities, who will be giving us a presentation on sort of what that is and how that focuses on some of the challenges with traditional procurement and equipment ownership. So that should be an interesting webinar. Again, thank you everybody for joining in, and have yourselves a great afternoon. Thank you.
Thank you, everybody.